Okay, so we need to make sure that we practice osmosis, and there's a little bit of diffusion and a little bit of active transport on this. So there's just a lot going on here. So with this first question, you're just kind of filling in the blank, completing the statement, answering a simple question. And I'm just going to roll through this really quickly with you all. So here goes. Number one, the cell membrane regulates and controls what kind of these move into and out of the cell. So remember that the cell membrane is in control of what comes into and out of the cell, and that's based upon concentrations. Number two, when molecules spread from an area of high to low concentration, it's called this. So this is a general term that you can use to describe that movement of high to low or with the concentration gradient. Number three, as molecules diffuse, they can create this, which is a difference in concentrations across space. So when you get into the specifics of this is where we start looking at percentages of solute inside of the cell compared to the percentages of solute outside of the cell in the solution. Number four, cell membranes are these, cell membranes are blank. This means that they only allow certain things to pass through. Again, this is where homeostasis begins, is with this particular characteristic of cells. And number five, kind of to piggyback on that, a membrane that would allow anything to pass through, regardless of concentration, would be called this instead. Number six, diffusion is the movement of molecules. Osmosis is the diffusion of this. Number seven, blank is the process of water molecules moving across the cell membrane. And since water, the movement of water is a type of diffusion, it's a type of passive transport. That means it moves from a high concentration of water to a low concentration of water until each equilibrium is reached. Number eight, the direction that water molecules move is determined by the difference in the concentration of this, which is dissolved in the solvent inside and outside of the cell. So when it comes to osmosis itself, there's several different ways that you can look at it. You can look at the movement of water just from high concentration to low concentration. So wherever there's the greatest concentration of water, wherever there's the lowest concentration of water, when you look at those two values, the water is going to move from high to low concentration until it's even. So you could think about if you had a flood and the water is outside, the greatest concentration of water is outside, and you open the door to your house, then that water is going to rush in. So it's going to move to that lowest concentration of water. So you can think about osmosis that way. You can also think about it in terms of the solute. So from the angle of the solute. So the water is going to move towards the solute. It's going to move in that direction of the solute. It's going to move to the greatest concentration of solute, which just happens to be the greatest concentration of solute is the lowest concentration of water. Number nine, osmotic pressure or osmosis pushes water blank to or away from the area of greater concentration of solute. So again, if I have a high concentration of solute, I have a low concentration of water. So you can look at this from a couple of different angles. And with your osmosis practice part 2, that's going to be a part of your cell test review, I have you kind of practicing it using those percentages of solute, using percentages of water, and determining the movement of water. Number 10, water molecules are pulled toward or pulled away from areas of lower solute concentration. So if it has a lower solute concentration, it has more water. So does the water move towards more water, or does the water move away from where there's more water? Number 11, the word hypertonic means what? So just hyper and hypo for 11 and 12, just think about prefix suffixes. Number 13 and 14, well, and 15 or more situations. So 13, a plant cell undergoes plasmolysis, or the shrinking of the cell membrane, when it's placed in a solution with a high concentration of solute. What type of solution causes plasmolysis? Okay, so there's a couple of things that you can look at here to figure this out. First, it tells you that there's a shrinking. So you can think about that. So when you did your osmosis notes, I gave you a little picture there to kind of connect with this particular type of osmotic solution. I gave you a picture of a couple little stick figures. The second thing you can look at is it says that it's placed in the solution that's a high concentration of solute. So it's a high solute. So that's the second key part to this question. So you could use the shrinking or the high concentration of solute. Number 14, an animal cell undergoes cytolysis, or stretching of the cell membrane. So cytocell lysis to break, when it's placed in a solution with a very low concentration of solute. So what type of solution causes this cytolysis? So again, two things, the stretching, or I can look at it from the other end and say not what happens to the cell, but to the solution itself. It's a very low concentration. And number 15, turgor pressure is the flow of water into a plant cell that causes the cell membrane to be pushed up against the cell wall and causes the sac in a plant cell to expand. So what is the name of this sac or this bubble that helps to maintain this turgor pressure by holding in the water?